Let's go on to instantaneous acceleration, and then we'll go on to vectors next. So instantaneous acceleration, as the definition implies, or as the term implies, is just acceleration at an instant. This is going to be acceleration at an instant in time. So we can find instantaneous acceleration by, let's start off by looking at our acceleration time graph. So let's look at our velocity time and acceleration time graph. So suppose we have a velocity time graph that looks like this. This is time in seconds, and v in meters per second, of course. Let's take a velocity time graph that looks like that, straight line. Or actually, let me do a curve. So let's take one that looks like this, something like that. Okay. And so what we can do is we can look at the acceleration time graph. So we can take the slope of the tangent line to the curve. Okay, so we take the slope of the tangent line to the velocity curve at different points on the curve. This will allow us to find the accelerations at each of those points, and then we can plot it on a graph to get acceleration time graph. Okay, so let me redraw it. So I'll draw this velocity curve again. And this is time in seconds. And we have something going like that. So if I take the slope of the velocity time graph at each of these points, so I can take the slope at some point here and the slope at some point here. And so different slopes. We can say that, note that slope is equal to rise over run, which is equal to change in velocity over change in time. Therefore, slope is equal to acceleration A. So we can say that acceleration A is equal to change in velocity over change in time. That was our definition for acceleration. So we can say that this is average acceleration. Slope is equal to acceleration A. This is basically average acceleration. Okay. So this is A average. So we can find instantaneous acceleration by shrinking the time to a very small point. Okay, we shall say that we find instantaneous acceleration by shrinking the time delta t to a point, i.e. let delta t approach 0. So what that means then is that A instantaneous is equal to limit delta t going to 0 of the average acceleration, which is change in velocity with respect to time. So we can rewrite this as dv dt. Okay. So instantaneous acceleration is the derivative of the velocity time graph, dv dt. So A instantaneous is equal to dv dt. Okay, any questions at this point? Okay, so A is equal to dv. Let's do an example on this. Okay, so we can try that. Okay, let's get some of the answers. What is average acceleration? 7. Okay. And instantaneous?
7.
Very good. And that's because what I gave you is a line. Okay, so A average is equal to change in velocity with respect to change in time. So that's going to be V final, let's say at a certain time, let's say 5 seconds, minus V initial at say 2 seconds, divided by 5 minus 2. And then for A instantaneous, the definition is dV dt, which is going to be d dt of V of t, which is 7t plus 2, so that's going to be equal to 7. Okay, is everybody following that?